Hello, welcome back. Next, we are going to discuss some problems related to moment generating function. Let capital X be a random variable with the probability mass function. Probability of x equal to q raised to x minus 1p. X equal to 1, 2, 3, etc. Find its MGF and hence the mean and variance. Okay, so by the definition, mxt is equal to expectation of e raised to tx. Expectation of e raised to tx. So summation, the same discrete distribution, summation x equal to 0 to infinity. X takes values 1 to 3. So x equal to 1 to infinity e raised to tx. P of x is q raised to x minus 1p. Substituting, we get e raised to t q raised to 0p. Remember that here this is a distribution q plus p equal to 1. It's also condition q plus p equal to 1. E raised to t q raised to 0 p plus x equal to 2 e raised to 2t q p plus then when x equal to 3 e raised to 3t q square p etc. So e raised to t and p taking outside, we get p e raised to t. Taking outside, we get it is first term is 1 plus q raised to 0 is 1 plus second term e raised to t into q plus q e raised to t square plus etc. Okay. So we know that 1 plus x square plus etc. is equal to 1 minus x all raised to minus 1. Similarly, here p e raised to t into 1 minus q e raised to t all raised to minus 1. 1 plus q e raised to t plus q e raised to t whole square plus etc. So expansion, the term is 1 minus q e raised to t all raised to minus 1. So MGF is p e raised to t divided by 1 minus q e raised to t. This is the MGF of the given probability mass function. Okay. Then the next question is find its mean and variance. So we have to generate moments, that is from this MGF. First moment, expectation of x. We know that expectation of x by differentiating MGF, d by dt of mxt is at t equal to 0 is expectation of x. Okay. Differentiating this with respect to t, p e raised to t divided by 1 minus q e raised to t, u by v form. So 1 minus q e raised to t into d by dt of p e raised to t is again p e raised to t minus p e raised to t into p e raised to t into d by dt of 1 minus q e raised to t all divided by 1 minus q e raised to t whole square. So it is 1 minus q e raised to t into p e raised to t minus p e raised to t into minus q e raised to t. Okay. All divided by 1 minus q e raised to t whole square. So multiplying we get first term is p e raised to t and second term p e raised to t into q e raised to t plus p e raised to t into q e raised to t all divided by 1 minus q e raised to t whole square. So here this get cancelled, then the term is remaining term is p e raised to t. So it is equal to p e raised to t divided by 1 minus q e raised to t whole square. Then at t equal to 0, at t equal to 0 it is p e raised to 0 divided by 1 minus q e raised to 0 whole square, which is equal to, which is p e raised to 0 is 1, p divided by 1 minus q whole square. P plus q is equal to 1, so 1 minus q is p. Therefore, p divided by p square, which is 1 by p. So expectation of x mean is equal to 1 by p. Then we have to find variance. Mu2 is equal to mu2 dash minus mu1 dash whole square. So we have to find mu2 dash. Mu2 dash is d by dt of d square by dt square of mxt at t equal to 0. So d square by dt square of mxt. Again differentiating the above, again differentiating this, we get d by dt of p e raised to t divided by 1 minus q e raised to t whole square. We get again u by v method. So 1 minus q e raised to t whole square into d by dt of p e raised to t minus p e raised to t into d by dt of 1 minus q e raised to t whole square all divided by 1 minus q e raised to t all raised to 4, which is d by dt of p e raised to t is again p e raised to t. So 1 minus q e raised to t whole square into p e raised to t minus p e raised to t into d by dt of 1 minus q e raised to t whole square is 2 into 1 minus q e raised to t into minus q e raised to t. Then all divided by 1 minus q e raised to t all raised to 4. So 1 minus q e raised to t is common, taking outside and get cancels. So the remaining term is 1 minus in numerator 1 minus q e raised to t into p e raised to t plus 2 p e raised to t q e raised to t. Okay. So multiplying we get first term is p e raised to t minus p e raised to t q e raised to t plus 2 p e raised to t divided into q e raised to t all divided by 1 minus q e raised to t whole cube. So we get p e raised to t plus p p e raised to t q e raised to t all divided by 1 minus q e raised to t whole cube. So p raised to t taking outside, we get p raised to t into 1 plus q e raised to t all divided by 1 minus q e raised to t whole cube is the answer. Then at t equal to 0, substitute t equal to 0, we get p into e raised to 0 into 1 plus q e raised to 0 all divided by 1 minus q e raised to 0 all raised to 3. So p into 1 plus q all divided by 1 minus q whole cube. 1 plus q is p into 1 plus q divided by p cube. P get cancels, and so expectation of x square is equal to 1 plus q divided by p square. Therefore, variance of x is equal to expectation of x square minus expectation of x whole square. Expectation of x square minus expectation of x whole square. So 1 plus q divided by p square minus 1 by p whole square. 1 plus q divided by p square minus 1 by p square. So q answer is q divided by p square. Okay. Next problem. For a random variable capital X, given expectation of x raised to r is equal to 0.6, for r is equal to 1, 2, 3, etc. Show that probability of x equal to 0 is equal to 0.4, probability of x equal to 1 equal to 0.6, and probability of x greater than 1 equal to 0. So we have the definition of MGF. MGF is mxt is equal to expectation of e raised to tx, that is and the expansion, we know the expansion mxt is because here expectation of x raised to r is given. So 1 plus t into expectation of x divided by 1 factorial plus t square into expectation of x square by 2 factorial plus etc. t raised to r x raised to expectation of x raised to r divided by r factorial plus etc. This is the expansion. So here expectation of x raised to r, given that expectation of x raised to r is 0.6, r equal to 1, 2, 3, etc. So substituting this, we get mxt is equal to 1 plus expectation of x raised to 1 is 0.6, 0.6t divided by 1 factorial. Again, expectation of x square is also 0.6, so 0.6 t square divided by 2 factorial. Again, expectation of x cube 0.6 t cube all divided by 3 factorial plus etc. Okay, so here we use some trick. This one can be written as 0.4 plus 0.6. Okay, and rest are the same. 0.6t divided by 1 factorial, 0.6t square by 2 factorial plus etc. So 0.4 plus 0.6 takes outside, we get 1 plus t by 1 factorial plus t square by 2 factorial plus etc. So it is 0.4 plus 0.6 into e raised to t. This is the answer. So consider we have mxt is equal to summation x equal to 0 to infinity, x, summation over x e raised to t x probability of x equal to x. Compare the corresponding terms with the mxt derived. The derived is 0.4 plus 0.6 e raised to t. So when we substitute x equal to 0 here, we get e raised to 0t is e raised to 0 probability of x equal to 0. So the corresponding term here is e raised to 0, 1 probability of x is equal to 0, corresponding term is 0.4. And in the case of when we substitute 1, probability of x equal to 1, probability of x equal to 0 is 0.4, and second term e raised to t, probability of x equal to 1 equal to the corresponding term, the coefficient of e raised to t is 0.6. Okay, and what will be probability of x equal to 3? Look at this, the total probability 0.4 plus 0.6 is equal to 1. So all the points 0 and 1 completes the total probability. So probability of x greater than 1 is equal to x equal to 3, x equal to 4, x equal to 3, 4, etc. So any term is greater than 1 is equal to 0 because the points 0 and 1 completes the total probability. Okay, thank you.